St. Elmo's fire is one of the most striking atmospheric phenomena ever observed, appearing as a glowing blue or violet light that clings to pointed objects during storms. Despite its name, it is neither fire nor combustion. Instead, it is a form of plasma created by intense electric fields in the atmosphere. For centuries, this mysterious glow inspired awe and superstition among sailors and travelers, long before science revealed its true nature. Today, St. Elmo's fire is understood as a predictable electrical process, yet it continues to capture the imagination due to its unusual appearance and folkloric significance. Hello, everyone. Giant Stonehead here. If you enjoy obscure science and forgotten history, you can support the channel by dropping a like, clicking subscribe, or sharing the video. I truly appreciate it. And now, let's talk about some spooky flames that aren't actually flames. To put it short, St. Elmo's fire is a corona discharge, type of electrical phenomenon that occurs when a strong electric field ionizes the surrounding air. This typically happens during thunderstorms, when large imbalances of electrical charge develop between clouds and the ground. St. Elmo's fire specifically is a luminous discharge of atmospheric electricity that appears on pointed objects. The process begins when the electric field becomes strong enough to strip electrons from molecules in the air, creating ions. This ionized air, also known as plasma, emits visible light. A key factor in the formation of St. Elmo's fire is the concentration of electric charges at sharp points. Objects such as ship masts, lightning rods, airplane wings, and church steeples create localized areas where the electric field is intensified. This allows the air around them to ionize more easily, producing the characteristic glow. St. Elmo's fire is often confused with lightning, but the two differ significantly in behavior and energy output. Lightning is a rapid discharge of electricity that releases enormous amounts of energy in a fraction of a second. In contrast, St. Elmo's fire is a steady glow that can persist for several minutes. It is also distinct from ball lightning, a rare and still poorly understood phenomena involving floating luminous spheres. While ball lightning appears to move independently through the air, St. Elmo's fire remains anchored to the sharp point where it started. The glow is most commonly blue or violet because nitrogen and oxygen, the primary gases in Earth's atmosphere, emit light in those wavelengths when energized. The same process is at work in neon lighting, where different gases are used to produce different colors of glass and tubes. This is to say that St. Elmo's fire is a low energy and continuous process rather than an explosive or energetic one. Long before electricity was understood scientifically, St. Elmo's fire was widely observed by sailors navigating stormy seas. These glowing lights, dancing atop ship masts and rigging, were often interpreted through religious and mythological frameworks that reflected how people of the time understood their world. The phenomenon is named after Saint Erasmus of Formia, also known as Saint Elmo, who is the patron saint of sailors. Medieval mariners believed that the appearance of the glow signaled the saint's protection during dangerous storms. Rather than being feared, it was often welcomed as a reassuring sight that the worst of the storm might soon pass. Historical records show that St. Elmo's fire has been observed for thousands of years. The Roman naturalist Pliny the Elder described similar lights in the 1st century CE. Ancient Greek sailors associated them with Castor and Pollux, twin gods who were believed to protect seafarers. Later explorers, including Christopher Columbus and Ferdinand Magellan, recorded sightings of the phenomenon during their voyages. These accounts demonstrate how natural phenomena were often interpreted as supernatural events in the absence of scientific understanding. St. Elmo's fire, with its ghostly glow in association with storms, was particularly well suited to that interpretation. In the modern era, St. Elmo's fire is most commonly observed in the air rather than at sea. Pilots report frequently seeing the glow on various parts of their aircraft when flying through electrically charged conditions. Common locations for the phenomenon in aircraft include wingtips, propellers, windshields, and nose cones. Those areas tend to accumulate electrical charge, especially when flying through ice crystals, snow, or near thunderstorms. Glow may appear as a faint light or as small flickering points along the aircraft's surface. While the appearance of the glowing light could be alarming, St. Elmo's fire is generally not dangerous in itself. However, it serves as an indicator of strong electrical fields in the atmosphere, which may increase the likelihood of lightning strikes. Pilots treat it as a warning sign rather than a hazard. Modern aircraft are designed to handle these conditions. They are equipped with static discharge wicks and grounding systems that help dissipate electrical charge safely. These features reduce the risk of more serious electrical events and ensure that the aircraft remains operational even in highly charged environments. St. Elmo's fire can occur in a variety of settings, provided the necessary electrical conditions are present. Thunderstorms are the most common trigger, but it may also appear during snowstorms, blizzards, or in volcanic ash clouds where static electricity can build up to significant levels. Any environment with a strong electric field and suitable structures can potentially produce the glow. Common locations where the St. Elmo's fire has been observed include ship masts and rigging, aircraft surfaces, church steeples and towers, power lines, and antennas. In each case, the presence of a sharp or elevated point plays a crucial role in concentrating the electric field, enabling the discharge. Even after its scientific explanation became widely known, St. Elmo's fire retained a strong cultural presence. Its dramatic appearance associated with storms made it a powerful symbol in literature and art. Writers such as William Shakespeare and Herman Melville reference the phenomenon in their works, often using it to symbolize hope, divine intervention, or impending danger. Its dual nature, both beautiful and ominous, made it a versatile metaphor. In maritime traditions, the glow is seen as a positive sign, representing protection and guidance. In other contexts, it could be interpreted as a warning or a supernatural presence. This ambiguity contributed to the enduring fascination with the phenomenon. St. Elmo's fire is a compelling example of how natural phenomena can bridge the gap between science and human experience. While it was once regarded as a supernatural omen, it's now understood as a straightforward consequence of atmospheric electricity. Yet its visual impact and historical significance ensure that it remains a source of wonder. By illuminating the mechanics behind St. Elmo's fire, modern science enhances rather than diminishes its beauty. The phenomena serves as a reminder of the complex and dynamic forces at work in Earth's atmosphere, as well as humanity's evolving understanding of the natural world. But what do you think? If there's anything you'd like me to cover next, let me know. I'll be posting here weekly. Until next time, thanks so much for watching.